Okay, so you can calculate how quickly an object is travelling just from knowing the mass and, let's say, the height that it's dropped from. So say we've got a question in your exam that says it wants you to know what is the velocity of a ball with a known mass, 0.8 kilos in this case, at the moment of impact if it's dropped from a height of 3.4 meters. And we can just use our three energy equations to answer that question. So the first energy equation that we've learned is this sort of total mechanical energy equation, which equals the sum of gravitational potential energy and kinetic energy. Each of these have their own equations, kinetic energy and GPA. So kinetic energy is 0.5 times mass times velocity squared. Hopefully you remember that. Good. GPA is mass times height times acceleration due to gravity, which is always 9.81 meters per second squared on Earth, at least. So using these two equations, we can work out the total mechanical energy of a system. So in this case, I like to draw a diagram just to think about what is the question wants to know. So we have a ball, and we want to know the velocity of the ball when it's dropped in a straight line down from a height of 3.4 meters. So it's traveled 3.4 meters down. Happy? Right, so we know that this ball weighs 0.8 kilos. That's the mass of the ball. So when the ball is at the top of its, when it's just being dropped, it's only moving downwards. So that's the top of its apex, essentially. That's the max height. And it's not yet moving. Well, that means we've got 100% of energy is GPA. I don't know how well the camera can see that from right now, but 100% is GPA, and because it's not moving, there's no velocity associated to it, so therefore the kinetic energy is 0% KE. Now if the ball drops all the way to the floor, there's now no height associated. So all of that, 100% of that GPA now becomes 0% GPA, because there is no height. So looking at the equation, if height is 0, then GP must be 0. Times anything by 0 is 0. Yeah? Good. But because total mechanical energy is always constant in a system, then if this is 0%, then kinetic energy must be 100% to maintain total mechanical energy. So there we have 100% kinetic energy. And we'll sort of explain this a bit better as we go on. But again, if you were 50% of the way down, so if you dropped it and you asked what's the velocity of the ball halfway down, then again you just use this equation or this theory, and you have 50% GPA and 50% KE. Yeah, and likewise 3/4 of the way, 1/4 of the way. Right, that making sense. Okay. Okay, once we've got this sort of diagram, we can start to work out, basically filling in these equations. So the first thing to do is, I guess, fill in the blanks for GPA. So we want to calculate gravitational potential energy, because that is going to tell us what the total mechanical energy is at the top. Yeah, and that's the only thing we can do, because this at the moment is 0. It's 0 joules. So total mechanical energy equals mass 0.8 times a height of 3.4 meters times 9.81. And I'm going to do that on the calculator. 26.68 joules. So total mechanical energy at the top is 26.68 joules of energy at the top. Now we're saying from this diagram that all of that energy gets converted to kinetic energy at the bottom. So if that's all kinetic energy, that means 26.68 joules of kinetic energy are at the bottom at the moment just before impact. Okay, now the reason we want to know kinetic energy is because, as we said here, the whole question is asking what's the velocity, and the only equation in which we can get velocity out of it is this kinetic energy equation. Here. So it's just a matter of rearranging that equation to get out your velocity. So I guess this is step 3 in the process. So we now know at the bottom total mechanical energy is all kinetic energy. So kinetic energy we have 26.68 joules, and we know that if we rearrange this equation, well, then velocity equals the square root of kinetic energy, which is 26.68 divided by half times mass, which is 0.8. Which is 8.17 meters per second. Velocity in meters per second. Yeah, so that's the cool thing about energy. You can literally, from two numbers, mass and a height that it's dropped from, you can work out how quickly an object, in this case a ball, is travelling at, which might be useful in your exam. Good.